This podcast will show you how to write a name from looking at the formula of a complex coordination compound. The compound is going to be broken down into two parts. We have the cation, we have the anion. In this particular compound, both the cation and the anion are complex ions. And I know that because they're enclosed in these square brackets here. When something is enclosed in a square bracket, it means that the ion contained inside of it is a complex coordination ion. When we name these, we are going to start by indicating how many ligands there are. And in the cation portion of this compound, there are 6. There are 6 ammonias. So the prefix meaning 6 is hexa, and the ligand name for ammonia is amine. So we have hexaamine, and then we need to name the metal. The metal is ruthenium, so hexaamine ruthenium. Hexaamine ruthenium. And now I need to give the charge of ruthenium, and that's going to come from these numbers right here. Think back to how we named very simple ionic compounds, and we would cross and drop the charges. So it looks like the charge for this portion, this ion here, is going to be a -2, and the overall charge of this ion here is a +3. Because when we cross and dropped, this 2 started up here, this 3 started up here. So if we say that the overall charge of this positive ion here was +3, let's look at what the charge of ruthenium has to be. Ammonia is a neutral ligand. It doesn't have any charge. So the entire charge from this ion here can only come from ruthenium. If the overall charge here is +3, that means that ruthenium's charge had to be +3. So I'm going to write that in here as a Roman numeral in parentheses. And now we just named the anion portion. Again, starting with the number and type of ligand. There are 4. That prefix is tetra. The ligand is chlorine, so the ligand name for chlorine is chloro, tetrachloro. The metal is nickel. When the metal appears in the negative portion of the ion, we change the suffix to ate. So instead of writing nickel, I'm going to write nickelate. When the metal appears in the positive portion of the ion, we don't change the ending at all. So this is tetrachloronickelate. And now I need to give the charge for nickel. Chlorine's charge is -1, and I have 4 of them, so I have a -4 charge. The overall charge on this ion here has got to be a -2. So if the overall charge is -2, what did the nickel have to be? What plus -4 equals -2? Well, that's +2. So nickel had to be a +2, so I'm going to go ahead and indicate that down here. Hexaamine ruthenium 3 tetrachloronickelate 2. That's the name of this formula.